In this video, I break down the solution for challenge number 9, King of Ethernaut CTF. So this video is part of a series of videos where we break down all the solutions for Ethernaut CTF, so if you like this kind of stuff, you're in the right place. So I explain the reasoning behind the solution so that you can learn from it and do it yourself in the challenge. So welcome to the DecentraWise channel. My name is Pedro, and in this channel we share information about all things Web3, blockchain development, and security. So if you like this kind of stuff, it's always fun around here. So let's go on, and we go to Ethernaut's website, and if you need to connect MetaMask and you don't know how to do it, and all these things, how to set up your environment for this CTF, you can add to our first video in this series where I explain everything to set this up. So let's move on to the challenge we want to solve today, which is the number 9, King. Let's click this, and we have our challenge. So let's open the console as well. We need the console open to interact with this with these challenges, and there we have our challenge. So let's check it. So the contract represents a very simple game. Whoever sends it an amount of ether that is larger than the current price becomes the new king. On such an event, the overthrown king gets paid the new price, making a bit of ether in the process, as Ponzi as it gets. So there are a lot of stuff like this on chain, and yeah, hacking Ponzi schemes is always fun. So the goal is to break this game. So we will beat the level if we can avoid anyone from becoming the king. So let's check the code. So we have a king, address, and the price, and one owner, which is probably the deployer of the contract because it's set here. Yeah, and the king as well. So the deployer is the king and at the start. And there is a price, which is the value that has been deployed with the contract itself. Okay, so we have a receive function. Okay, the constructor is payable. The receive function checks if the message value is higher than the price, or the message sender is the owner. Okay, so it will send back the message value, which is the value that we send to the contract, and we will become the king. That's it. And the price will be the next value. So the price variable is holding the last value, which we have to overcome by sending. Okay, so with this we need to define a strategy. So what will be our strategy? We need to first, let's grab our instance, and there we go. MetaMask confirm. There we are. We have our instance, and there we go. And we now can inspect our contract to see what's the status. So first, let's get the balance that we have in our instance. So await get balance instance. Let's do this all to string. So we have 0.001 Ether. Sounds good. So what do we need? We need to break this so that no one else can become the king. How can we do that? The only way that we have is to become the king. First, we need to become the king, and we need to prevent the next king from being successful in the receive function. So we are doing a transfer here. So we can, if the contract is relying on the transfer function, we can revert when we receive the value, and that will break the transfer function, and it will revert all the time. So no one will be able to become the king after us. So it seems like a good approach to break this. So what can we do? To become the king, we will need to pass this. So we are not the owner, of course. So we need to have a higher value than this. We need to pass a higher value than this. And it has to be done by a contract, because our contract needs to revert when people want to send back the money. And that's the whole attack. So let's head over to Remix, and let's create a contract here. New file, and this is king.sol. There we are. And let's bring this so that we don't have to type it all. There we go. And we have our contract, king, attack. There we are. So we will need to have a victim address, of course. Address, public, victim. We need to have a constructor that receives the victim address, and this constructor needs to be payable, and we get the victim and we save the amount. So we need to also have uint 256 public amount. There we go, and we save the amount here. So we save the amount that we sent to the constructor so that we can do the attack. So send that value to our victim. And now we need to have the receive function that reverts so that no one can become the king after us. So we do receive external payable, and then we do the magic, which is revert. Boom. And anyone that sends us any amount will be out of business. And now we just do our attack function. So function attack, public or external, whatever. And so our attack will be sending our amount to the contract. So how can we do that? So we just do the regular transfer, but let's do it the right way, not with the transfer function or the send function. We right now the best way to do transfers in Ethereum is by using the call with a value, because of the gas needed and so on, so that we can support contracts and all that. Okay, so let's do it. So bool, it returns a boolean, which means that if it has been successful or not. So sent, and we ignore the data because we don't need it, and victim dot call. So what we will be calling nothing and sending an amount. So let's do it. We will send value with this call, amount, and we will call nothing. Okay, so this is the way to send money to or Ether to the contract the right way. And let's do the check if we have been successful. So if not sent, revert, so that we can just know that we had some problem sending the amount. And that's it. I think we are good to go. So we will call the attack. The attack will send the money that we sent with the deploy to our contract, and it will become the king, and no one else will be able to become the king after us, not even the owner of the contract. So let's check this contract. So we need to deploy it with this instance, okay, and we have to send more than this. So we need to, or at least equal. So it can be the same. So we will send 0.001 Ether to the contract. Let's do that. So we need to connect to MetaMask, and we need to send Ether. We will have to send. It's a bunch of zeros. Let's just send one ETH, and it's enough. So it's Sepolia ETH anyway. So let's send one ETH. It's easier to type because the interface doesn't allow to put dots, and so we will have to count 18 zeros and do all that. So yeah, one ETH is enough, and we can put the address here to deploy the contract, and boom, there we go, and we deployed. We have our contract deployed here, and it has one ETH, as you can see. So, and we have our attack function. So let's check here. We still have, let's check the king contract, king. So the king is this address, 3049, blah, 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 which is the level address, the deployer of the contract. Okay. So let's become the king. Let's go. So we become the king by pressing attack and confirm in MetaMask, and boom, it's done. So let's see if we became the king. It is different. So it's probably the address of our contract, FCDB. Let's check. FCD, blah, blah, blah. Okay. So it seems that our contract became the king, and hopefully when we submit the instance, the owner will try to become the king after us, and they will fail because there's no way, right? So let's try. Let's check that, and accept in MetaMask, and boom, there we are. We solved this challenge with this contract. So this is it, guys. It's not a very hard one. We just needed to understand how to break a transfer function, and how to not allow that transfer to execute after us. So this is the solution for this, and I hope you understood what is going on here. So we just prevented the game from working, right? It was not a very interesting financially, so we could break even. I just didn't, because I just didn't want to write all the zeros down to send the right value, and we prevented anyone from becoming the king after us. So we will be the king forever. So we break the game, and that's it. So I hope you had fun in this episode, and if you got any value out of this, just smash that like button. It's free and it's down there. And subscribe for more, because we are sharing videos all the time about Web3 and blockchain development and security. So stay tuned for more, and Thanks for watching and see you in the next video. Cheers. Bye-bye.